single projectile. No warhead. No propellant. Just raw electromagnetic force accelerating a metal slug to Mach 7. At that velocity, it punches through any warship armor on Earth. The era of explosive munitions is ending. Pure kinetic violence is replacing it. How do you launch a projectile at 7 times the speed of sound? You build 2 parallel conducting rails. You bridge them with a sliding armature. Then you push tens of millions of amperes through the circuit. The magnetic field does the rest. The core principle is the Lorentz force. Current flows down one rail, across the armature, and back up the other rail. This generates an enormous magnetic field between the rails. The armature, trapped in that field, is violently accelerated forward. There is no chemical combustion. No expanding gas. Just pure electromagnetic thrust. Inside the railgun barrel, the armature carries a tungsten penetrator rod. This rod is encased in a lightweight aluminum sabot. The sabot stabilizes the projectile during acceleration. The barrel itself is lined with copper alloy rail conductors. These conductors must handle extreme current density. The electromagnetic forces generate intense plasma arcs. The plasma erodes the rail surface with every single shot. Managing this erosion is the central engineering nightmare. The energy demands are staggering. A single shot requires roughly 32 megajoules of stored energy. That is the equivalent of detonating 8 kilograms of TNT. This power comes from massive pulsed power supply systems. Capacitor banks charge over several seconds. They dump their entire load in milliseconds. The current pulse peaks at over 6 million amperes. The rails experience forces that try to blow them apart. The conflict is thermal destruction. Every firing cycle generates temperatures exceeding 10,000 degrees Celsius at the rail contact points. The copper rails melt. The armature partially vaporizes. The barrel has a finite lifespan, hundreds of shots at best. The dance is in the materials science. Engineers use refractory metal composites for the rails. They experiment with graphene-reinforced copper alloys. The barrel is designed as a modular replaceable insert. Cooling channels run through the rail assembly. They circulate dielectric fluid between shots. This fluid absorbs heat without conducting electricity. The thermal management system is as complex as the gun itself. But surviving the launch is only half the problem. The projectile exits at 2,500 meters per second. At that velocity, atmospheric drag generates extreme aerodynamic heating. The sabot peels away. The tungsten penetrator is exposed. It must survive thousands of degrees of friction heat. Tungsten is chosen for a reason. Its melting point is 3,422 degrees Celsius. It is the highest of any pure metal. The penetrator maintains structural integrity through the entire flight. At impact, the kinetic energy is catastrophic. The 10-kilogram slug at Mach 7 carries over 31 megajoules. That energy is focused on a contact area smaller than a coin. No armor system on any warship can survive this. Modern naval armor uses rolled homogeneous steel. Some ships add composite ceramic layers. But kinetic energy penetrators at hypersonic velocity defeat them all. The projectile does not explode. It simply punches through and transfers its energy as superheated shrapnel. The internal damage is devastating. But what makes railguns truly terrifying is cost. A guided missile costs between $1 and $4 million per shot. Railgun projectile costs roughly $25,000. The magazine never runs out of chemical propellant. It only needs electricity. A single warship with a nuclear reactor has virtually unlimited shots. Taiwan Strait. The hostile surface action group pushes through contested waters. The formation includes 2 guided missile destroyers and a heavy cruiser. Their Aegis-class radar systems scan the horizon. They expect anti-ship missiles. They have trained for missiles. Their CIWS guns and interceptor missiles are ready. They are not prepared for what comes next. The shore-based railgun battery receives targeting data. The battery is positioned 200 kilometers inland. The electromagnetic launchers charge their capacitor banks. The firing sequence initiates. The first projectile leaves the barrel in a flash of superheated plasma. It crosses the coastline in under 4 seconds. The tungsten penetrator climbs on a ballistic arc. It reaches peak altitude and begins its terminal dive. The cruiser's radar detects the inbound contact. The system classifies it as a ballistic threat. But the projectile is tiny. Its radar cross-section is smaller than a bird. The tracking solution struggles. The CIWS engages. The 20mm rounds fill the sky. but the incoming slug is moving at Mach 6. The engagement window is less than half a second. The CIWS misses. The penetrator strikes the cruiser's forward deck at a 70-degree angle. It punches through 3 layers of steel. The kinetic energy converts to thermal shock. The forward magazine detonates. The destroyer captains watch in disbelief. There was no missile warning, no exhaust plume, no infrared signature to track. The projectile was effectively invisible until impact. Their countermeasures are designed for threats they can see and intercept. This is something entirely different. The railgun battery fires again and again. The cycle time is 6 seconds between shots. Each projectile is independently guided using GPS and inertial navigation. The targeting data updates in real time from overhead satellites. The lead destroyer attempts evasive maneuvers. It turns hard to port. The second projectile adjusts its flight path during the terminal phase. Tiny control fins on the penetrator shift its trajectory. The slug impacts the destroyer's engine block amidships. The ship loses propulsion instantly. Superheated tungsten fragments tear through the engineering compartment. Steam lines rupture. The destroyer goes dark. The second destroyer launches a salvo of interceptor missiles toward the coastline, but the railgun battery is 200 kilometers inland. The interceptors lack the range. They fall harmlessly into the ocean. The third projectile is already inbound. It strikes the second destroyer's combat information center. The ship's command capability is eliminated in a single hit. The entire engagement lasts under 90 seconds. 3 capital warships disabled or destroyed. Total ammunition cost, approximately $75,000. No friendly aircraft were risked. No multi-million-dollar cruise missiles were expended. The railgun battery simply recharged and waited for the next target. But there are constraints. The railgun's barrel degrades with every shot. The power supply requires massive infrastructure. The projectile lacks the explosive payload to guarantee kills against hardened underground bunkers. It is a ship killer, a precision surface target eliminator, not a replacement for every weapon. The tactical window demands perfect targeting data and clear firing solutions. The future of naval warfare is not about bigger explosions. It is about faster projectiles. Electromagnetic railguns are rewriting the rules of engagement. Thanks for watching. Subscribe for more breakdowns of cutting-edge military technology.